let's just remind ourselves of something. If I say, hey, we got f function, we got f prime, and we got f double prime, what does f refer to in the real world? The position. I was like this. F prime, velocity, f double prime. That's it. You guys, we need those tattooed. And I will put those up here because that's muy importante. We're going on a straight line, left and right. Between 0 and 5, the velocity is given. So again, you guys, this totally dictates what we need to look at. So if I were you, I would circle the word velocity and I'd circle the function. So I know that that's f prime because it can be misleading that they just named it v and not v prime. Okay. And then they said the position is s. Find all the times where the particle changes directions. Okay. It said, okay, how do I know something changes directions? What's my velocity right now? What's my velocity right now? Positive. What's my velocity right now? Negative. So my sign changed, right? So you guys, I would write that note to yourself. It says when the particle changes directions, that's when the velocity changes signs. That's how we're going to know that. And we get a calculator. What can we do with our calculator? Could it graph this? What is this a graph of? Let's go take a peek. So let's go grab our calc. When we go to our y equals screen to graph it, look what they actually want our x's to be. Between 0 and 5. So you guys, let's all go to our window. Let's see if we get ours to match now. And now that we want our x min to be 0 and our x max to be 5, so that's the only thing you need to change in your window. Now hit graph. Now do ours look a little similar or no? Yeah. You guys, this is a graph of velocity. So you guys, if I were us, let's go ahead and say, all right, velocity looks like this. Boop, nothing specific. And we don't need to be accurate, but I want you to draw this graph of velocity. Sketch it. When I say draw it, I mean sketch it. You guys, we said that this particle is going to change directions when the velocity changes signs. What are all of these y values? I'm sorry. What are all of these y values here? Those are all negative y values, right? What are these y values here? What are these y values here? Aren't they still positive? Anything above the x-axis is positive. Anything below the x-axis is negative. So how many times did it change directions? Twice. It's going to happen here and here, you guys. We need to know what this point is and this point is. How can my calculator do that for us? What would those be called? Those are x-intercepts, but that's not an option if we do second calc. If you do second calc, yeah, what did you say, Thomas? Those are zeros. Yep, zeros are x-intercepts, Sadie. They just call it the zero. So everybody go second trace, which is second calc. Option 2 for zeros. And for these zeros, it says what's the left bound. You need to move your little cursor to the left of that 0. So I'm going to go a little to the left of it, hit enter. I'm going to go a little to the right of it, hit enter. Then it wants a guess and just hit enter. You guys, you don't need to get closer for that guess. What did it give you as that that 0? 0.536. Liv, you gave me 3 decimals and I love you for that. 0.536. That's one time it changes directions. Guys, we've got to go find the other 0, which is over here. We're going to do the same thing. Second trace, option 2 is 0. We got to move our cursor all the way back over now to get to the left of this 0 and get to the right of it. So I'm going to get to the left of it. I'm going to hit enter. I'm going to get to the right of it. I'm going to hit enter, and I'm just going to hit enter one more time for my guess. And I'm going to get 3.318. Let's keep this party moving then. Here we go. Is the speed, do we care about which direction we're going with speed? I don't care if I'm going negative 75 miles per hour or positive 75 miles per hour. It said, is the speed increasing or decreasing when t is 4? Say that again. Okay, I love that. You guys, let's go do trace 4, hit enter, and on your calculator, it probably will give a little cursor. Does it show you where that is on there? Will you do trace 4, enter? Okay, we're all a little zoomed in. Do me a favor, do zoom 6. Go back to zoom 6. Don't know why my calculator's doing this. And then do zoom 4 again. Trace 4, enter. Oh, and it still doesn't show where it is. Okay, but Thomas says, I know if my graph is looking like this, If my graph is looking like this, Thomas, you know at 4, we're somewhere down here. And those velocities are negative, but aren't they just getting bigger negative? So it's going faster in the left direction. So yeah, I love that. Is the speed, oh, shoot, give the reason. We got to do some math behind this. Yesterday, we had to talk about velocity and acceleration for speeding up and slowing down and their signs. So do me a favor. We got to find the velocity at t is 4. And wouldn't that just be, given my velocity function, aren't I just going to plug in 4 there? Yeah,
Negative 11.476.
Agreed. So do you agree my velocity when t was 4 was a negative number?
Yep.
We also have to go compare my acceleration when t is 4. Now, your answer is right, Thomas. Your answer is right. We just have to back it up with this calculus answer. So the acceleration when t is 4. Acceleration is going to be the what of velocity? The prime of it, the derivative of it. Exactly. You guys, will your calculator find the derivative of it? Yes. Check this out. It'll actually do it on the screen. We could have done it from the home screen, but you guys, you can do second calc or second trace. Do you see a derivative anywhere? Option 6. So go hit 6, and then I want you to type 4 and hit enter. And does it give you the derivative at 4? Did anyone get negative 22 point something? Yeah. Yes. So you guys, it just calculated the derivative for you. So we can just say v prime at 4 was negative 22.296. Anyone remember, if the signs of my velocity and acceleration are the same, is it speeding up or slowing down? Speeding up. So we're going to say speeding up because velocity and acceleration have the same sign at t is 4. If we don't say t is 4, we aren't getting the point. This is the reason they'd need for that, right? So Thomas, you knew that right away. You're like, dude, I know it's speeding up, but we have to do this kind of explanation. Annoying. Here we go. It says it's position. So Liv, this time they named position x of t. That one seems reasonable. It says, when is the particle at rest? And you guys, this one doesn't say calculator active, so we don't get a calculator. What's my velocity right now? Negative. What's my velocity right now? What's my velocity right now? 0. So when something is at rest, when the particle is at rest, that means my velocity is 0. Those are little ones that we got to remember. Can we go get our velocity if this is position? We can do that. Wouldn't that be x prime? Without our calc, we got to do this. Here we go, people. Derivative of 2x cubed. Oh, yeah. 6t squared minus 42t plus 72. Thanks so much, Lena. You guys, do you want to O2 or toot? Which one's way easier? You think O2's easier?
Why would you not just O2 that?
Because we have that 6 in all of them, our numbers would be huge. I'd have to know what 72 times 6 is. I don't know what that is. Yeah, so let's take that 6 out, you guys. Let's take that 6 out, and I'd have a t squared minus 7t plus, say that again? Yeah, 12. Now, Thomas, we're going to say that's going to be equal to 0 because my velocity is equal to 0. That's when it's at rest. And Thomas is like, okay, tooting now is way easier. What multiplies to be 12 adds to be negative 7? Okay, girl, negative 3 times negative 4 is positive 12 and it adds to be negative 7. Livia, snap, snap, snap. You guys, at what times is my particle at rest? 3 and 4, Mr. Reichert. 3 and 4, is that an answer? Boom. Why did I get to ignore the 6? Do you agree? T minus 4, I'm going to write this out that you didn't have to do this, Liv. T minus 4 equals 0 when t is 4, right? T minus 3 equals 0 when t is 3. When does 6 equal 0? Oh, it doesn't, so we don't have to worry about it. But Liv, if it was 6x, if they had a 6x in common, then x is 0 would have been another time that they had in common. So that's a good call. Because it's just a constant, we get to ignore it because 6 is never going to equal 0. 6x is a different story. Great question. So good. Okay, you guys, 2016. Okay, the velocity. Okay, you guys, they said velocity. Velocity is given, they called it V of t, those jerks. We can call them jerks. They called my velocity V. We're going to call them jerks then, okay? Which of the following statements describes the motion of the particle at 1? How do I know if something's moving left or right if my velocity is negative or positive? Well, they gave me velocity. We do get a calculator. Could I go find my velocity at 1? How would I find my velocity at 1? Just plug in 1. I love that. I'm going to write this off to the side. V of 1 equals, I'm going to go to my calculator, and I'm just going to type in a 1 into that velocity function. And so I'm going to type in square root of 1, a little redundant, that's just 1, minus the cosine of e to the 1. And we're going to make sure that we are in radians. Did anyone get 1.912? Great. So you agree it's moving to the right. I'm getting rid of A and I'm getting rid of C because they both said it's moving to the left. How do I find acceleration? It's the blank of velocity. The derivative of velocity. So you guys, could I go find V prime at 1? Because I don't have to do this by hand, I can jump straight to V prime of 1 and not V prime of X or V prime of T by letting my calculator do it. You guys, let's go on this home screen and we can do math, calc, we can do, second trace, and say I wanted to find the derivative. Why is it doing this? Are you guys just on your home screen? Don't do second trace, do math. Option 8. My bad. On that home screen, we just want to say math, calculate that derivative for me. I'm going to say root x minus cosine of e to the x. Why am I putting x's in? Because here is now where I'm going to say, okay, here is when I'm going to say I want that when x is 1. Enter. Did anyone else get 1.617? My acceleration was what sign? Positive. So what are we going to say? B, you said, Sade? So good. Again, calculator active says velocity is given by this. What is the acceleration at 4? With a calculator, what can I let my calculator do? Find the derivative. You guys, I just want V prime at 4. So I'm going to do that same thing on my home screen. I'm going to hit math option 8. Please calculate the derivative for me. 3 plus 4.1 cosine of 0.9x when x is 4. Calculator active. Notice that. Look at all these calculator active ones. Whew, so many. It says position is oh wait, whoa, I was misread. It says position is x. And they gave us this. What do you think this is? That's my velocity. If x is position, if position is x, and then they're telling us dx dt, this right here is my velocity. Now they said the acceleration is 0 at what t? This is a little different. They're not saying when, they are saying, when is the acceleration 0? When is the acceleration 0? How are we going to go from velocity to get to acceleration? The derivative to Wilson's point. Could I do that on the graph? Could I do that on the graph? Okay, let's go to our graph, and I'm going to go to my y equals, and I'm going to say math. You know what, you guys, check this out. Do math 8 right in your y equals screen. Look at this other way to do this, Wills. Check this out. I want my acceleration. So I could always say, go calculate the derivative of this right here in this part menu of my calculator too. So we got negative 10 x to the 4th. We can't do it on the home screen. We want to be in the graph. So you could have just typed in my velocity here if you want. You don't have to do the derivative of it. but we do want to be in the graph screen. Oh yeah, you guys, now. And it's saying when x is, you're like, I don't know what x is. I want the graph of the whole derivative. You guys, you're going to put when x is x. And by saying when x is x, it's going to give you the graph, wow, the graph of the derivative. Mine's giving you something in the background. Don't mind that. Does yours look like mine? So what we're staring at, do you agree this is a graph of acceleration? What we're staring at looks like something like this. Woo, woo. And that's acceleration because we asked it to graph the derivative of velocity. Okay. You guys, it says the acceleration is 0 when? They want to know what's my x value when this equals 0. What am I going to be looking for on my graph? That 0. So you guys, if I'm looking for this right here, I'm going to do second trace. I want the 0, which is option 2. We got to go to the left of it. Wilson's gonna get a little closer to his than he did last time. To the left of it, a little to the right of it. And did anyone get 0.831? Whew. This is hard, you guys. So I would be writing down kind of how we did these things. But that was tough. Okay, calculator active again. And it says we've got this velocity. Boom. We got this velocity. Where is the speed increasing? What graph do you want to look at if we want the speed? Do I want to look at velocity or acceleration? I think probably the velocity, right? Let's go see. Let's go to my y equals screen. Let's go to our y equals screen. You could do it from acceleration. I don't think it's going to be as intuitive. Let's just look at that graph of velocity. Negative x cubed plus 2x squared plus 2 to the negative x. Does anyone else's graph look like mine? Yeah? Okay. So, do you agree our graph is looking a little something like this? And this is velocity. Where is the speed increasing? I don't care which direction I'm going. This is velocity. What are these y values doing now? Getting closer to 0. So I'd say it's probably slowing down here. My y values are getting smaller here. What are my y values doing here? Getting bigger. So I'd say my velocities are increasing there. What are my y values doing here? Yeah, they're getting closer to 0. Then what are my y values doing here? Increasing. So you guys, we want to know what these highlighted regions of my graph are. How the heck would I do that on my calculator and figure out like what that point is? Where is that on the graph? This is the minimum. So you guys, we got to go find this minimum. And then what would we find? What would we look for this? The maximum. Let's start with that and see if that gets us our answers by itself. So we're going to do second trace. Min is option 3. We got to go to the left of that min. We're going to go to the right of that min. And we're going to hit a guess. And I'm saying 0.177. Anyone else? 0.177. I don't care about the y because these are x intervals. To find that max, I'm going to do second trace. Maximum is option 4. The left of that max, the right of that max, and I got 1.256. 1.256, don't care about the y because these are x intervals. Is that right there enough to answer our question? You're saying you see this here, Liv, and you see it there, but we do know that there's a second, so we can assume it's E. But let's go verify. How would I find this point, you guys? This is a 0. So I could go find this just to verify that, Liv, to your point. Let's go make sure that is. So if I said second trace, option 2 is a 0, I want to know where that 0 is. And I did get 2.057. And look what they said, 2.057. And it's going to go on forever. That's good.